Okay, we have a series and we're going to try to prove if this converges or diverges. So, but just by looking at it, we know that this is going to diverge. We know that this is going to diverge because this is 1 over the square root of n squared is its main behavior, and this would just be 1 over n, and this series is a harmonic series. So we know that this diverges, but we can't just say that's why it diverges. We actually have to do a comparison. And so if you remember with these comparison tests, we have to have something here that diverges, a series that diverges, and if this series here is greater than the series which diverges, then this also diverges. So we already know that this is going to diverge. Now we need to go and prove it somehow. So how could we prove it? How could we use a comparison? What is this going to be larger than? We could pick anything. We could pick anything. So as long as this is actually larger than something which diverges. And this thing here is similar to this one. So what would we do? Could we do 1 over the square root of n squared? That would be very simple, but unfortunately we can't. Because if you look at this, this isn't actually greater, because this denominator is greater than the denominator there, which means that this series is going to be smaller. This entire series is going to be smaller when you have a larger denominator. So no, we can't use that, unfortunately. So what can we use? Well, we could use anything we want as long as it's nice and similar to this one. So let's make our life simple by doing this, because that easily factors. That easily factors, and then here we have n plus 1 squared. We would have n plus 1 squared, and this would certainly be a larger denominator. This would be certainly a smaller denominator, and therefore a larger series as a whole than this one. So all we had to do was pick strategically a denominator that was going to make this entire series smaller than this one. And this is what we did. So now we have 1 over n plus 1. And with 1 over n plus 1, we can... Now this is very similar to 1 over n. This is approximately 1... n equals 1, infinity, 1 over n, and we know that diverges. We know that diverges. This is greater than something which diverges. Since this diverges, and this is greater than that, this must also diverge.